Let us understand the machine learning life cycle and what are the personas involved in a real time. This is a very simple life cycle I have mentioned here. So let's start with the problem statement and how are we addressing via machine learning or AI and what value we are expecting from the machine learning. It is very important to frame the problem statement before we are starting with the machine learning and whether it's really need a machine learning or not, or this can be solved with a simple rule engine. Then once the problem statement is defined and how are we going to address, let us gather all the required data. You can take a data from the public data set or your organization proprietary data set, or you can use the AWS data exchange if you want to use the wide variety of industry data. The next step is explore the data. And this is where the data scientist who has a domain knowledge, let's say if you're uh, trying with the genomics data, you may expect somebody who has a very good understanding or the domain expert of the biology or genomics will understand the data and create a baseline. This is very important. We cannot expect 100% accuracy. If the 100% accuracy is then the model is overfit. Okay, so it is always better to create what is expected baseline and what kind of data we got it, whether need to augment the data or the data what we have is clean enough, or we need to we need to get use this data and use a data set from the other data set to create a new feature. Based on that, you create a baseline for your accuracy and the data. The next, this is where the machine learning engineers will come into the real play, as well as the data scientists, of course. They identify what kind of model we are going to be used, what kind of algorithm need to be used, and how are we going to train the model, whether this model is uh, contains a large data set and does it need a distributed training, or it's a small data sets. Based on that, how are we going to train the model, what kind of algorithm we need to be to use. Is it going to be a classic machine learning problem like a regression, a logistic regression, or the linear regression, or is it going to be a large models like NLP or the computer vision? Based on that, they will understand what kind of more algorithm to be used, how are they going to train the data, and whether they need a GPU or CPU. If it is a CPU, AWS has a wide variety of um, instances which we can use for training the model. And if you can use uh, AWS Trainium, which is a cheap on training the model at the scale, and you can then we can evaluate the model with the test data, and we need to make sure the accuracy, whatever the accuracy we are expected, is met or not. If the accuracy or the baseline what we expected is not met, then we need to go back to this second step of gathering more data or augment the data and build more data to build a new level of model. Now, good. If in case if your accuracy is met, then comes the next part. How are we going to host this model? Is this model need to be a batch processing? That means we know it's going to be served for the downstream for any other application or model, or how frequently it need to be run, like it need to be run over the night every day, or it need to run every 2 hours. And based on that, we can create a batch processing. Or is it going to be a real time inference, like you are hosting via API, or you are hosting your uh, language model like Alexa over the real time inference? Based on that, you will have a right decision. How are we going to host? And if it is a real time inference, there is a different level of challenges. We need to make sure the accuracy is met, okay, with the real time data, because it's unknown data. And whether the throughput is going as expected. We need a standard model monitoring in place, okay. And if there and at the same time, we need to collect the data in a real time. Let's say if you're giving a new voice, take an example of Alexa. It's completely trained with a human, a men and women voice. The baby is giving a voice to invoke the Alexa, It may not understand. Okay, I'm not saying that it is not understanding just example it. Say it may not understand, then we need to collect the real-time data and again give us an input to the cycle, and then we need to retrain the model. So the real-time inference bring a different challenges. We will have a separate section to understand how we can host the model at the scale. There are different patterns available or recommended by AWS. We'll go through those information in upcoming section. Okay. Then I just touched upon this in the previous section, but I also want to touch upon and again the AWS recommended or the AWS identified personas involved in the MLOps or the machine learning lifecycle. Okay, yeah, it starts with the product owner. I think I have highlighted before. Okay, the product owner is really important to get the uh, feel of the product and get the feedback from them. Okay, how is it performing, whether this application is performing at the right accuracy or better throughput, or is it working well in all the region. So the product owner feedback is very important. The data scientist, yeah, lead data scientists, they will identify what solution need to be done, and they will make sure they're doing a before going to the production. They will evaluate, make sure the model is build model trained model bringing a good accuracy or expected accuracy, and it is covered all the what feature made this model, like I say, responsible AI. And say as a QA, how the DevOps the quality team, QA team will do for the application. The lead scientist will play it as a QA. And data scientists, of course, they will part of the all the life cycle. They build a model, evaluate the model, version the model, train the model. And you can use SageMaker will provide all help us on all the life cycle. We will see as a demo as part of the next section. Then ML engineer, they will bring a new algorithm. Most you can use AWS provided foundation algorithm, or you can build down your own based on your need. Then, of course, you need a data engineers to help on crawling the data, creating the data, and giving the clean data. And the base, we may need a network team or organization team, make sure the security is hardened enough and the data is governed enough, and everything we build using infrastructure as a code. So these are all the personas involved, and these are the operations involved in the machine learning, and these are the technology or the AWS services we are going to be touch upon. Okay, we will delve deep into each and every component and how are we going to use it, how we are integrating it. Okay, stay connected. Before addressing the SageMaker, how it is, how we can do some demo, we will address what is the current MLOps challenges we are facing in the next section. Stay tuned.